Okay, kids. Today is Monday, the 26th. We have 3 weeks of school. Your homework tonight is on page 329, 2 to 30 even. You're going to graph numbers 20 through 30. There are 6 graphs, okay? So on the 2 graph papers, one should read, one should say 5.5 notes, direct variation. The other one should be the assignment. Okay? So before you leave, I'm going to staple your progress report to the graph so that when you see it tonight, you'll get a sign and bring it back tomorrow. Okay? We're going to review for a test tomorrow. We have a test on Wednesday over sections 5.1 through 5.5. Okay? Yes, we're reviewing tomorrow for a test on Wednesday. You have progress reports are due with the bash on Friday. We have basketball here on Thursday. We have pictures on Wednesday, 7th period. I think that's it. Okay, let's get started. Direct variation. This lesson looks confusing. It really isn't. This is kind of a precursor to slope tomorrow, where we officially talk more about slope. Okay? So let's get started here. Direct variation. Pretty much, direct variation sounds kind of like what it is. It's directly varying that point. Direct variation is another fancy word for slope. Remember that the slope, that number tells you how to move the points, right? So the points have to be moving the same speed every time to make a line. But what happens if the point doesn't move the same speed? Yeah, it makes like a crooked something line. It's not a line. It's not linear, right? It makes a crooked line. So direct variation. There are 2 ways to think about direct variation. The formula right here can be written as y equals kx. This is the equation. What does this solve for slope? What is slope? The change in what over the change in what? Change in y divided by the change in x, or y divided by x. This is the slope. Or sometimes we'll refer to this as the constant of variation. Very simple. Don't make this hard. Okay? You're only looking for the slope. You're graphing the lines, just easy lines tonight. Equation and or slope. Remember that slope is the change in y over the change in x. Questions so far? No? Remember that it's also the rise divided by the run. Rise over run. You always go up or down, but you always run to the what side? Left or right? Like I'm running forward, think about running forward. Same thing. You always run to the right. Okay? You never run to the left. Always run to the right. You either go up or down, but always to the right. Why? Because if you go the other way, that makes it a negative, and the line will be backwards.
So it's always to the right.
Okay. It could be positive, or it could be negative. It depends. You ready? Okay. Direct variation also means that the slope is consistent. Okay? That means that the line goes up, the dot goes up and over the same time every time. The difference is that the line always crosses 0, 0. In direct variation, the line always crosses 0, 0. If it doesn't, it's not a direct variation. Y directly varies with x. That means the slope is the same every time. So the line is always crossing the 0. It's 0, 0, always. I'm going to teach you how to tell the difference. Questions so far? Okay, let's move on. Let's do number 1 together. It will make sense to you as we go. Look at number 1. Is it solved for y equals yet?
No.
It isn't, right? So we know it's going to be a line because it's y. It could be y equals. To solve this, subtract both sides of the sign by x. Bring down the y. Y equals negative x plus 7. Okay, let's stop right there and wait for everyone to catch up. Whenever you're solving for lines for the rest of the chapter and the rest of the year, solve for y. Because eventually you're going to be graphing it. You're going to be using graphing calculators for the rest of the year. Okay? And until we learn it. So then you get negative x plus 7. Now, how do you know if it's a direct variation? Okay, but here, by looking at it, because there's a number at the end, see this number? That actually crosses at 0, 7. Guess what? This is not a direct variation. So if there's a number at the end here, if there's a number right here, then it's not a direct variation. It does not cross at 0, 0. It never will ever cross at 0, 0. So think in your mind, if I were to take this finger and cover this up, what does that equation tell you? What kind of slope is that? What kind of function is it? Somebody you're related to.
My mom.
It's your mother function. But it's the negative mother function. Go back and review section 5.1 very closely. You should be reviewing your notes tonight. Okay? We'll come back to that later. This is no. Compare this to number 2. Daniela, can I solve for y here?
No. Yes.
Yes. I can solve for y. Here's what I need to do. Just like on the homework, on the review, no, UPS check today. Subtract 4x on both sides. Cancel out. Bring down the negative 3y. Bring down the negative 4x. But do I really need to bring down the 0? No, that's understood. You don't have to. You don't have to bring it down. Okay?
It's not going to change anything.
No, it won't change anything. But we're not done yet, though. We still have to divide by negative 3. Then you get y equals. Be careful right here. This is what I've been harping on.
It's going to be positive.
Why is it positive right here? Negative divided by negative is positive. In this case, it's y equals positive 4/3. Do you see a number next to the x?
Yeah.
Okay, this right here will be your slope, positive 4/3. So can you see that in your head?
Yes.
It goes up 4 and to the right 3. But is there a number? Is there a plus sign or a minus sign next to it?
No.
Because there's no plus 7 or minus 6 or minus 2 or whatever, this is a direct variation. It will go up 4 and over 3, up 4 and over 3, starting at 0, 0. Questions? Yes? Then it goes, if it had been negative, go down 4 but to the right 3. Down 4 but to the right 3. That will still be direct variation because it still didn't have a number at the end. It still starts at 0, 0. Yes, ma'am? Okay, look at number 3. Look at number 3.
You just divide by negative 8, I guess.
Yeah, this is only one step, right? Divide by negative 8. Y equals, be careful. Negative what? Negative 3x. Okay, in your mind, what kind of slope is this, Esteban?
Direct.
Don't waste my time. Let's go. What kind of slope is this?
Negative.
It's a negative slope. Okay. Does it have a number at the end?
No.
Nope, because it didn't have a plus 4 or minus 5 or a constant number. This would be a yes. Okay, that is a direct variation. It starts at 0, 0. You go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. We'll practice graphing on the other one. Let's do a couple more and we'll be done with this page. What happens if you're not given anything? Like you're not given an equation?
You're supposed to create your own.
Oh, you can? Okay, but using the equations that I told you earlier. So here's another way to solve this problem. Y equals kx, or k equals y over x. This equation tells you the equation. It's weird. Okay. This one tells you the slope. They're both the same. They mean the same thing. Yes. K and M, it means slope. I need to write that down, don't I? K is slope. I know. I'm sorry. It's confusing. You don't say. I don't know. Okay. Let's look at this one real quick. Substitute in numbers. So what number, pick this point right here. What number do I have? 2. Okay. And then leave the k alone, but what number is x? Negative 4. I'm just substituting in. This is not difficult. Solve for k. Divide by negative 4. And then you have negative 1/2. Okay. We have to see if the other point. If the other point is also negative 1/2, it makes a line. If it's not, then it's not a line. Okay, so pick another point. Sorry, I should have done this one separate. Okay, so pick this point and this point. So negative 5 equals 10k. Divide by 10. Do I also get negative 1/2 when I reduce? Because they're the same on both sides? Yes, it makes a line. Yes, it makes a line. Yes, it makes a line.
Do we have to do both of those in order to solve it?
No, pick 2 points and make sure they match. Yes.
Well, what if y is the little y over x point over there?
Which one here?
Yeah.
Okay. This one is used to, actually, you know what? This one's used to find the equation, or the slope. So this is another way to solve this one. So I'm going to continue this problem, okay? Same problem. Would you agree that k is a slope?
Yes.
Give me a point for y then. Pick the one that we haven't done yet. Do this one. Negative 1 is y, the change in y over the change in x. What's the x then? See how they all match?
Wait, so the answer has 3 fractions?
No. They have to be the same. The same. The slope is all the same. That means the line goes up. No, it goes down 1 over 2. Dot. Down 1 over 2.
Either one of the little equations.
Because they mean the same thing.
I don't get the second one.
This one right here, we're just substituting in y over x. That gives you the slope.
And then is that, and you just like simplify?
Yep.
And then that's your answer?
Yep. Do number 6, please, and we'll be done in about 6 minutes. And number 6. Do number 6. Okay, here we go. Typically, if you have a table like this, which equation is easier?
The second.
First one.
Second one.
The first one's okay, but the second one is actually a little bit simpler because all you do is you just have to figure out what is the slope. This one tells you the slope, right? This one tells you the slope. So then you have the first one, please. 8 over 6. Which reduces down to 4 over 3. Okay. Do the second one. Pick another point. 10 over this point right here. So same thing. Y over x. 12 over 10. 12 tenths reduces down to. Well, what do you notice there? They're not the same. This is no. This is not a line. It makes a curvy, wavy thing. It is not a line because they're not the same. It's not a line.
Oh.
Okay. Let's switch over to the graphs. Oh man, I have a lot of time. Let's do the graph really fast because we're already out of time. Okay. Ignore the bell when it rings. This shouldn't be that bad. Calm down. All right. On tonight's homework, you'll have 6 graphs, and all you're given is a point. That's it. Is this if let's say if you were given negative 3, 9, if you plot the point negative 3, 9, does that tell you anything?
No, it's
That tells you nothing. It just tells you that, okay, there's a dot right there, right? We can use direct variation to tell us what the equation is and how to graph it. You can either use y equals kx or k equals y over x. This is the slope. This is the equation. Use your head. What do these points mean? X and y. Excellent. Okay, tell me what to do. Substitute it in. I'm going to show you both ways. 9 equals negative 3 k. Divide by negative 3. K is my negative 3 over 1. This is your slope. What kind of slope is negative 3 over 1? It goes down 3 to the right 1. Down 3 to the right 1. Did I start this on the wrong spot? Oh, I did. Where did it cross at? 3, 1. Yeah, so it should cross right here, right? Oh, sorry. It should always cross at 0, 0. Always. Always. If it doesn't, it is not a direct variation. Yes. But they all will be, though. Or, if you do this side right here, k equals y over x. What's y? And 3. Don't leave your stuff yet. And then your slope is still negative 3 over 1. It tells you the same thing. So in your graphs tonight, like this is my example. So on your graphs, it should always go through the 0, 0 point. Okay? So how do we figure it out? We use the two equations. Anything else? On your go ahead and take your progress report.